My name is Jon Gifford. I'm the founder and CTO of a company called Loggly, and we do logging as a service. So software as a service, but with a very specific focus, which is logs. And we don't care what the logs are. They can be system-level logs, they can be application-level logs, they can be stuff that you log out of a web page to track page views, anything at all. Send them to us, and we'll take care of them. What we mainly provide is just a single place to put all your logs and search on top of that. We have archiving as well, so you can keep your logs for as long as you like. And actually, we already have alerting. So we just launched another site called AlertBirds that will let you monitor the logs that you send to Loggly and alert you when something happens that you're interested in. We launched earlier this year, so we haven't been going very long. One of the interesting things as far as search is concerned for us is that every single customer has their own index, which may be sharded into multiple shards. But basically every single customer gets their own completely isolated search index to use. At the moment, we have something like 8,000 shards in the system, about 7 to 8 billion documents, document being a pretty loose term. Most of our events, our average event size is somewhere around 300 to 400 bytes. And we, on a normal day, we're doing about 3,000 to 5,000 events per second coming into the system, which works out to about 1 to 1.5 megabytes a second. So it's it's reasonable volumes. It's not spectacular, but it's interesting. And basically, our sort of value is that we use search on top of whatever you send us so that you can go digging around in your logs and find stuff. And we use facets so that you can graph things and all of the typical stuff that you would do with search if you're just exploring. This is what the site looks like. We have a dashboard that shows you how many events you've sent in, where you've sent them to. We have this idea of an input, which is whatever you want it to be. In our case, we typically make it an application, and devices, which is where the events are coming from. And then we have a shell that's deliberately designed to look like a Unix terminal. And you just go in there and type search, and then whatever you want to search for, you'll get your results back, or graph, and you can get a graph back. So logging search is actually a really, in some cases, it's a very degenerate search problem, because people don't really care about what happened a month ago. They really care about what happened in the last hour or day, or maybe week. So really, our search problem is to try and stay as close to real time as we can, and provide good performance for the last, say, week for most people is good enough. In fact, the last day for most people is good enough. And we can get away with making a lot of simplifying assumptions. So for example, time is our score. If you do a search on us, you get stuff back in time order, and that's it. There's no scoring, there's no relevance, there's no nothing. It's just time. And we never have updates. Log events don't get changed. They get logged, and they happened, and they're done. We have I guess, relative to a lot of other search problems, a large number of small documents. Like I said, somewhere around 300 to 400 bytes is a typical event. So out of all of this, we end up with a very simple, in theory, a very simple model for building our indexes, which is we can just shard by time, and time is basically when we receive the event. So all of our indexes are basically built sort of from time zero onwards, and we do some pretty aggressive sharding up front, so that we can keep the hottest stuff, which is, at the moment, it's 5 minutes. We can keep that updated frequently, but without having to deal with merges and any of the performance implications of that. So, and then as we go back in time, the shards get larger and larger, and we just merge them so that we end up with sort of sane-sized chunks, like a day or a week or an hour. So nice, simple index lifecycle. So we're using SolrCloud, and we started using it almost 2 years ago, actually. And Yannick and Mark, they helped us out immensely 2 years ago to get us sort of over the hump. It was, at that point, it was I think it was a branch or maybe a patch on a branch. But we basically got it working in, a couple of weeks, got it working to the point where we could start making it really work, but in a couple of weeks. So it was pretty impressive. Solr we used because I've been using Lucene for a long time and playing with Solr for a shorter amount of time. But basically, the fact that it's extensible and does facets and does native migrations and does decent caching were all very important to us. And having worked at places like Technorati, where we had a very highly tailored Lucene, I didn't want to deal with all of that stuff again. I didn't want to get locked into some particular version of Lucene and have to go through the pain of an upgrade, meaning rewriting a whole bunch of code that had been changed in the meantime. So Solr seemed like an easier way to kind of add on the stuff that we wanted without sort of getting too bogged down in the details of what really is going on in the underlying layers. Zookeeper is the big new thing, I guess, in SolrCloud. It's basically, for us, for SolrCloud, it just maintains the state of the entire cluster. So every node, every shard is in Zookeeper, and every node can access all of that data. So basically, you get kind of automatic cluster config. If you spin up a core on Solr, it automatically gets registered in Zookeeper, and then every other node knows that that shard or that core is available for search. And the other thing that we've used, the thing that we've done that takes advantage of that is that we don't really have any masters in the system. So we just distribute all of the intelligence about what gets indexed where, what shards live where across the entire system, which has a lot of advantages, some disadvantages, but it's actually worked out pretty well for us. So the big advantage for us is that you basically can't kind of go headless because there is no head. So you can't lose your master and suddenly not be able to do things. Everything can just carry on without needing to know anything much about anything else. I've already mentioned the registering, deregistering. All the Solr configs are in Zookeeper, so we can, for example, change the way that we index a particular field just by updating Zookeeper. The only thing that's not there is SolrXML, which is special, and basically it just tells the Solr instance what shards are available on it. That information is also in Zookeeper, but as a way of just quickly bootstrapping Solr, it works well, and it means you can, if you have problems, you can go in and just whack SolrXML and get on with your life, which we've had to do a couple times. We've also extended the default SolrCloud Zookeeper data. So we have some Loggly specific configs, and we also put performance data into Zookeeper. So when we're signing up, I don't know, 10 to 20 customers a day at the moment. When a new customer signs up, we need to pick an indexer for their data. And so because we have the performance data sitting in Zookeeper, any of the nodes can just look at that and say, oh, this guy is the least busy, assign him to that indexer, right? So stuff like that is actually really nice. And you could do it without Zookeeper, but it's a lot easier to just do it inside of Zookeeper. The other thing that we've done is we have a bunch of other applications in the system as a whole, And we've just kind of taken the approach that, that Mark and Yannick set up with cloud and extended it for all of those other applications. So they, for example, we use 0MQ for all of our messaging between the applications, and we store the 0MQ configuration, so the port and the protocol, 0MQ protocol, inside of Zookeeper, so that when applications start up, they can just look in Zookeeper and say, oh, I should be talking to that guy, and I know that he's going to be talking on this port on 0MQ. So having Zookeeper around just makes a whole lot of stuff a whole lot easier. I've already talked a little bit about this. We have one index or collection, as they're called, in SolrCloud per customer, sharded by time. We migrate from node to node, just using the default Solr replication. We've had to break it a little to make that work, but it works. The way our system is set up, we have configurable layers of nodes. So the indexer nodes build 5-minute shards, and then we have a second tier that pulls those 5-minute shards and merges them up to about 4 hours, I think. No, up to a day. And then we have a final layer that is just a week of data. So you can imagine if a shard gets created up here, it'll get migrated down here as a 5-minute shard, and then migrated off this guy as a 1-day shard down to the weeklies. And we take over merging completely. So merging is always fun. I just decided that it was simpler just to completely take it over, so that if we couldn't avoid the CPU cost, we could at least sort of know and be able to predict when it was going to happen and try and deal with it in a more sort of deterministic way than just leaving it up to Solr and playing with configs and praying that you got them right. So I've already mentioned the fact that we don't have a master. So SolrCloud, meet reality. So like I said, about 18 months ago, 18? Actually, that's wrong too. About 2 years ago, everything pretty much worked. We had to fix a couple of to-dos that were in the code that have actually since been fixed in trunk. We changed the way we select shards for search because we have a slightly different model of sharding and customers in general, or rather, our idea of a collection in SolrCloud is actually a customer, and our idea of shards is slightly different from what I think most people will use SolrCloud for. We hit a Zookeeper performance wall, which I'll talk about in a little bit more detail, and we've pulled most of the Zookeeper code out of Solr into an external jar because we use it, like I said, in our other apps. So we added a bunch of utilities and all the kinds of things you do when you take something and put it in production. Some to-dos, a couple. So the facet stuff wasn't done. Obviously, if you're going to draw graphs, you need facets. So we did that, and it's since been done probably properly. We've got graphs, so it works, I guess, as far as we're concerned. And unregister, when you unregister a shard, at the time that we grabbed it, it didn't do anything. Now, we actually clean out Zookeeper if we really unregister a shard, as in remove it from the system. So we just walk up the Zookeeper tree and remove potentially even the collection for the shard. And there's one more, but I'll get to that in a bit. I mentioned that we changed the way shard selection works. So this was kind of an evolutionary approach. The first approach was we wanted to sort of fake out the way that Solr does its shard selection, and by default you have to hit a shard, some shard. In cloud you can hit a collection. We decided that we didn't want to know what collection we had to hit in, or rather we decided we wanted to pass the collection to hit as just a parameter. So we just set up a single core called logly, and we just hit that. And that worked fine for quite a while. But we eventually scrapped that because we didn't want to spin up yet another core, and I'll get to why in a little bit. But basically, we now just have an admin handler that services our search requests. And when we make the and it's basically just a proxy, if you like, for the actual search requests, which use native Solr search requests. Inside of that handler, we currently do sort of short-circuiting of the search results. So if you come in and you're a customer who has, a month worth of data, and you're searching for the last day, we can very quickly enumerate what shards that maps to, and then we basically just do an iterative search on those shards to get you the results, which means that the main reason for that was to reduce the search load on the system. And it works fine, and most of the time you find the stuff you want in the first couple of shards, and search is done within, tens of milliseconds. We can't do that with facets, obviously. You need to actually hit everything. So facets, we just use the regular parallel multi-searcher. So we've been playing performance whack-a-mole lately. In the last few months, we've had to deal with two fairly major issues, and we've got one issue that's kind of plaguing us right now. So I'm going to talk a little about the first two. The last one, just to give you some context, we spent some time at the beginning trying to figure out the perfect way to deal with migrations and where shards should be and all of those kind of things. And we kind of needed to do that because we had so little data and so few customers that you kind of had to be smart about where you put things. We're kind of getting to the point where we don't really care that much anymore, so we can just dumb it right down. We're not trying to optimize for performance of the sort of lower level shards. We still optimize for performance of the indexers, but then from that point on, we've got enough data flowing through the system that we can essentially just pick a box and just send everything to that box, or sorry, everything for a customer to that box. So we can get rid of lots of ugly code, which is nice. This is the to-do that really hit us, and the to-do is right there. Possibly incremental update rather than reread everything. So this has been fixed, by the way, but I thought Mark mentioned it yesterday, but I thought I'd tell you about it because it's kind of an interesting story. So there's a couple of things going on here. One is that every time you want to find out where something is in the system, you go get this thing called CloudState. And for us, because we have a lot of moving parts, and because we want to make sure that we give you the right search results, what we were doing was we were pulling that state. We were forcing an update of that state, which when we started out was fine, but when we ended up with 8,000 shards in the system and we were reading all of the data for those 8,000 shards, and I can't remember, it's something like 1,000 or 1,500 customers at this point. It just was not fast. And there was some locking that I think I put in stupidly. And so basically we were just completely log jammed on trying to figure out where things were in the system. It basically slowed us to a crawl. Everything still worked, it just was very slow. The other thing that slowed us down was in the default SolrCloud. I'm not sure whether this is still true, possibly not. Actually, no, I know it's not. There were watches for every collection and every shard because the idea was you want to know when things change. You want to know if someone adds a shard or removes a shard or updates a shard or whatever, right? And so we had 8,000 shards, which means 8,000 watches. We had 15 nodes or so. And every time we created a new shard inside a collection, that would trigger an update to all 15 nodes, which would then reread everything, right? So, and we're doing a lot of updates to the state. So basically, we were just shooting ourselves in the foot. And I was really glad to hear Mark talk yesterday and say that all of these things look like they've been fixed. So, in the immortal words of the late, great Steve Jobs, we just avoided holding it in that way. We stopped watching things. We now currently don't care about collections at all or shards. We don't watch them at all because we, instead of watching for some external event coming in and saying, hey, this thing has changed, we do it basically lazily. We get a request that requires that we know about some collection, and then we just go pull it, which is the third point on here. And you can do that in no time, like generally way below 10 milliseconds. So just turning off watches sort of gained us a massive amount. Going to incremental updates, and actually this is kind of incomplete. Not only do we do incremental updates, but we never keep, or we rarely have the complete state of the cluster in any one particular node. So basically, we just pull the data that we need to service the requests that we're dealing with, which works way, way better. There are some cases where you're going to need to know, where some nodes are going to need to know a lot more than other nodes, but they're rare, and even in those cases, the incremental stuff works pretty well. I've already mentioned the on-demand updates, and we went from potentially up to 20 seconds, and even 20 seconds was probably optimistic. I was seeing 30 and 40 seconds to sub 10 milliseconds pretty much these days, and we're doing hundreds of updates to Zookeeper every minute. So that was a huge win. So the next thing that kind of bit us, we are not running a lot of boxes. We're running about, I think, 20 boxes or so at the moment. So all of our boxes are massively oversubscribed in terms of the number of shards that they have on them. We typically run somewhere around 200 to 400 shards per box, and these are not big boxes. They're quad-core 16 gig boxes. So we have a lot, way too much index data on these boxes. As I said before, though, luckily that doesn't really matter because most people don't search that data, so it's not, chewing up a lot of resources. But particularly on the indexes, we see a huge amount of context switching. Our indexes run typically in the 200 to 300 collection range. So they're indexing continuously into 200 to 300 shards. And so they're context switching like crazy. We're using a lot of RAM periodically, especially for mergers, especially for customers who send us a lot of data. We're doing lots of GC because of merging, warming, searching, all of those things. And on a bad day, and we had a bad day a few weeks ago, we can end up with thousands of shards on a box. So if, for example, an indexer can't push the shards it's working on down the stack, it'll just keep indexing, which is the right thing to do. You want to keep indexing. But one of our boxes 3 weeks ago had 16,000 shards on it. It wasn't searching at all but it was still indexing. So that was kind of the worst case that we've seen. I've seen, you know, up in the 1,000 to 1,500 range, relatively common, and the thing just keeps going. So, you know, it's pretty good. The problem when you get up into the hundreds of shards is that when you try and start up Solr, CoreContainer will open all of those cores before it will do anything, let you do anything else. And which meant that if we had a box that was, you know, 100% in one thread doing garbage collection and just locked up and was stuck there for 20 minutes and we had to bounce it, then you could be waiting, you know, minutes for the thing to come back to life. So we introduced this thing. So now we basically put shards to sleep if we think that they're not going to be used for a while. And about 50% of our shards are just asleep. So what that means is that it's not loaded by CoreContainer. It's all of the information that is pulled out of Solr XML is available inside of CoreContainer, but we just don't spin up the core. So we've basically halved, or actually a little more than halved, the number of cores that we start up on the sort of the bigger boxes, which is really nice. We added the state, the awake or asleep state, to Zookeeper. And to do this, basically, I just wrapped Solr core in a class that just maintains this state and some other stuff, but basically that's all we do. And the nice thing about this, the nicest thing about this, is that when we start up Solr, it's up in typically 5 to 10 seconds, as in it'll start accepting requests. And they can be search requests, and they can be search requests for cores that have not been started yet, because we know what all the cores are. We can just automatically start a core up if a request comes in for it. So it's actually, this has made our lives a lot easier. So I better move on. I'm sure everyone's had this experience where you write some great code and put it in production and suddenly realize that you have no way of maintaining the data that's driving it. Zookeeper, in the version of Cloud that we got, was kind of like that. So we added a bunch of stuff. We added a way of just nuking stuff out of it, and it's deliberately called nuke because it's kind of a last resort thing. We also added things that let us specifically purge shards for a specific collection. So if an entire collection is deleted, we can just purge everything for that collection in one hit. And then restore if, for whatever reason, Solr XML doesn't get written properly and the thing crashes and you start up and suddenly you realize you're missing a bunch of shards, you can just restore them. And just go look in the file system, find them, and put them back in the system. Purge node is a good one. Who here is on EC2? Okay, how reliable are your boxes? We've been losing boxes. You lose boxes on EC2. And when that happens, you need a way of kind of purging information about that node from the cluster. So that's what purge node does. It just lets us, if a box goes away or if we take a box down, we can just purge all of the information from inside of Zookeeper about that node. And we sort of return all of the stuff that got purged so that if you need to, you can go rebuild stuff or whatever you need to do. But that was also a pretty important one. And balance is kind of a direct access to the code I was talking about before that kind of figures out where everything should live. So you can just directly prod a box and say, balance this collection. It looks wrong to me. Fix it. And it will go ahead and do that. And upload, which is also useful. You can just upload whatever file you want into Zookeeper, which the default stuff doesn't do. Is that true? Yeah. We've spent a lot of time, the stuff that we've done that's kind of special, I guess, and the kind of stuff that I would imagine a lot of people wouldn't have to do. We've spent a lot of time on shard and cluster management. So our sharding, for example, is all, it's different than regular sharding, and we had to write it all from scratch. Like I said at the beginning, Solr plugins make this stuff very, very easy. Pretty much everything we've done is just using plugins, which I love. Zookeeper makes management easy. We made pretty minimal changes to Solr. The biggest ones are these three. So we use 0MQ to move data through the system, at least up to the point where it hits a Solr box. And so we added a 0MQ handler that you can just connect to and start writing stuff to. And inside of that handler, it figures out what collection the event needs to go to and sends it to the appropriate indexer, which kind of completely bypasses all of the HTTP input stuff, and has been super reliable. And we're not really stressing it at the moment. I mean, we're not really putting enough events through the system, but you know, I've tested this up to like 50,000 events a second, turning off indexing, because you can't index that fast on the boxes we're using, but you know, you can do like significant volumes through 0MQ without even breaking a sweat. I've already mentioned the sharding, and I've already mentioned the logly core stuff. We also added a bunch, probably getting on now for about 20 different API, admin requests that we use, that the rest of the system uses rather, to communicate with Solr. So we can, for example, our front end can communicate to Solr and say, hey, here's a new customer, do something, like make them a collection, start indexing, whatever. The things that feed Solr data can talk to Solr and say, here's a new customer, or here's the data for the new customer, and Solr can bounce back and say, no, I don't want it, and force it off to someone else, that kind of thing. So just all the glue kind of stuff. Again, it's all just straight in the admin handler. I've already mentioned almost all of this, I think. The live node stuff is a really interesting part of SolrCloud, I think. So Mark mentioned it. There are ephemeral files inside of Zookeeper that only exist for as long as the application that created them is alive, plus or minus 5 to 10 seconds. And the really nice thing about that is that if you get a search request, you can look, you can figure out what shards you want to hit to service it, and then you can look to see whether they're actually alive or not. So you can avoid making a request that you know is going to fail, and you can do simple load balancing based on that, right? So that's all just part of SolrCloud. We use it so that we can track all of the other applications and whether they're alive or not. So just the idea that you could use this thing to tell you the state of every application in your cluster was something that was really easily extendable. And one-off things where you can go through, you can just make a REST request, get some JSON output, slam it through some Ruby or Python or whatever, awk, and figure out what happened to some part of your system. The other thing to say actually is Zookeeper has been ridiculously robust for us. We have never, ever, ever had an outage, a Zookeeper outage. We're running 5 Zookeeper instances. They're sharing a box with Solrs that are pretty heavily loaded. We've had those boxes disappear, and spun up new ones, spun up a new Zookeeper instance, and it automatically just synced with the remaining Zookeeper nodes. So absolutely love how reliable it is. Other stuff we use. So we're on, I've already mentioned we're on EC2. We use S3 for archiving. We use syslog-ng to gather data from people who want to send it to us over syslog, although we're about to replace that. We use ZeroMQ for moving the events through the system. So we have, essentially we have syslog, and then we have a thing called the collector, and then we have a thing called the splitter, which is actually a router. From the collector to the splitter to Solr is all ZeroMQ. And it's awesome. If you get a chance to play with it, play with it. We use MongoDB for stats. One of the reasons for that is that, yeah, we could do facet calls on Solr to get stats on how many events have come through. But then you're doing super expensive search requests when you can do them once and store the results in Mongo. So it's just basically a big cache for stats. We use Node.js for our HTTP inputs. And the app I showed you way back here is all written in. That's it. Any questions? Okay, so the question is experience on EC2. So as far as we can tell, we haven't had any sort of systemic outages. We are pretty convinced that the reason we're losing EC2 nodes is because we're running our JVMs too hot, and they're just locking up in GC, and then you know, the thing just basically hangs. So there's about a 50-50 chance that our nodes come back to us, which suggests that it's simply an out-of-memory problem. But then when they don't come back, we have no way of telling why they didn't come back. But no, we haven't seen anything systemic. And you know, I think you know, there's some bad things you could say about EC2, but I think for us it was exactly the right thing to do because we had no idea whether we had a product. So you know, you'd be kind of crazy to do a startup and go out and spend $100,000 or $200,000 on hardware to build a search system that might only end up having 2 customers. So you know, as a way of scaling the company as much as the product, I think you know, it works pretty nicely. I think there's an inflection point beyond which you're just paying too much for elasticity that you don't use. So for example, with us, our elasticity is always sort of up. So we have never like turned boxes down. We're just getting more load and we're just going up. So and we're sort of going up at a predictable rate. So you know, at that point, you start to wonder why. I mean, there's a lot of advantages to being on EC2 and being able to spin up a box in 10 minutes, but you know, there's also a cost. So the question is, do we use spot instances? And the answer is no. The reason is that we have yet to kind of automate box flapping, if you like. So if we use spot instances and they just disappeared, then that would make our lives too hard. So once we automate sort of bringing boxes up and down, yeah, we could potentially move to spots, and particularly for indexing, actually, it might work really well. And so, but no, we haven't really looked at it just because there's a lot of stuff you have to do to make it reliable. So, oh yeah, okay. So the question is, how are we managing all of the process life cycles, you mean, roughly? Okay, yeah, we use Supervisor, and it is almost awesome, except for restarts, which don't. So what's updating Zookeeper is Solr and the applications themselves. So we you just spin it. Basically, you just spin up a Zookeeper quorum, tell all the Solr boxes where it is. They connect to it and put the information that they need to put into it, and so do our other apps. So, and we actually use Puppet and RightScale. So RightScale lets you tag a machine with a particular role. That role means that when you spin the box up and run a Puppet script to bring it online, the role tells that script all of the subscripts to run, which install all the right stuff. And sure. So the question is about Loggly itself and how you can send data in so that you can slice and dice it, kind of to find data from different services or servers together or apart. Yeah, so that's what these guys are for. So the inputs are basically you define what they are. These are hard to read, but basically for us, what we do, we log out of our production servers into a separate instance. And our inputs in that case are just our applications. So Solr, Collector, Splitter, Django, yada, yada, yada. So that lets us log all of our Solr logs, for example, to a single input. But then over here, we also have devices. So devices are basically machines. So when you come in and do a search for on your Solr logs, you'll see, when you come in and do a search, if you just do a straight search, you'll see logs from all of your inputs. If you narrow it to a particular input, you'll only see that input. And if you narrow it to a particular machine, you'll only see that machine. And if you narrow it to a particular input plus machine, you'll only see that machine's logs. So it's, it's pretty simple, I think. So the question is, how is performance of ZeroMQ? It's staggering. I mean, it's phenomenal. It's an order of magnitude better than RabbitMQ, for example. I mean, and so it's not as reliable, but it kind of almost doesn't need to be, because nothing is in transit long enough for anything to go wrong. If we're using, and now I'm blanking on it. I'm blanking on the name of there's multiple protocols you can use with it, but the one we're using will actually queue inside the sender if the receiver goes away, and then the receiver will come back up and start again. So you have like this little window of stuff that got sent to the receiver, assuming that what happened is the receiver crashed. So there's a window of events that could get lost there. But in general, we haven't seen that happen at all. So, the ZeroMQ guys are very clear about the fact that it's not, 100% durable, 100% reliable, any of that stuff. But in terms of moving data around your system, it's so fast and so lightweight that if you can kind of build the durability in somewhere else, then I would recommend using it. How do we resurrect supervisor? So supervisor runs locally on the box, right? So if supervisor goes down, we just restart it.
Is that something you do manually?
Yeah, it does. I mean, it's funny you should ask, because the first time it happened basically was about, first time it's happened for us, I think, was about 2 weeks ago, was we lost supervisor on a couple of nodes. So.
Okay.
Okay, great. Thank you.